Hi everyone, I am Dr. D. Tamilarasan, Assistant Professor, Department of Mathematics, K.S.Rangasamy College of Technology. Now we have to discuss about the diagrammatic and graphic representation in the topic of statistical methods course. This is the list of contents we discussed in this video. Diagrammatical representation of data, types of diagrams, and graphical representation of data. First, we have to see the diagrammatical representation of data. That is, a diagrammatic presentation of data gives an immediate understanding of the real situation to be defined data in comparison to the tabular presentation of data or textual representations. The main concept of diagrammatic presentation is a technique of presenting numerical data through pictograms, cartograms, bar diagrams, and pie diagrams, etc. A graphical representation is the geometrical image of a set of data. It enables us to think about a statistical problem in visual terms. It is a mathematical picture. It is an effective economic device for the presentation, understanding, and interpretation of the collection of data. The main advantages of diagrammatical representation is diagrams are more attractive and impressive, easy to understood, useful in comparing relationship between two or more sets of figures, useful to making comparison, enable statistical problems in a visual form. Next, types of diagrams. The types of diagrams are one-dimensional diagrams. So that means line diagrams or bar diagrams. Two-dimensional diagrams such as rectangles, squares, and circles or pie diagrams. Three-dimensional diagrams such as cubes, spheres, prisms, cylinders, and blocks. Then pictograms, then cartograms. Next, we have to elaborately discuss about the one-dimensional diagram. One-dimensional diagram is that diagram in which the only length of the diagram is considered. That has line graph, simple bar diagram, multiple bar diagram, subdivided bar diagram, percentage bar diagram, broken scale bar diagram, deviation bar diagram. So simple bar diagram means simple bar diagram comprises of a group of rectangular bars of equal width for each class or category of data. Multiple bar diagram means this diagram is used when we must make a comparison between two or more variables like income and expenditure, import and export for different years, marks obtained in different subjects in different classes. Then subdivided bar diagram means it is constructed by subdividing the bars in the ratio of various components. Percentage bar diagram means it is presented on a percentage basis, is known as percentage bar diagram. Broken scale bar diagram is used when the value of one observation is very high as compared to the others. Deviation bar diagram are used for representing net changes in data like net profit, net loss, net exports, net imports, etc. Next, we see the line graph. It is the most common graphical representation by plotting x-axis on horizontally while y-axis vertically. Find out the intersecting point or origin and join all intersections. For example, we know about the cricket scoring each over. That is representation. We already known that. Here given the one of the stock market line chart is there. You should be noticed down. Then bar diagram. In a bar graph, data is represented by bars. The bars can be made in any direction. The bars taken of equal weight and start from a common horizontal or vertical line and the length indicates the corresponding values of statistical data. When do we use bar diagram? The data are given in whole numbers. The data are to be compared easily. Types of bar diagram. It has two types of bar diagram. One of the thing is simple bar diagram. That means only one variable can be represented. Next one is multiple bar diagram. It means many variables can be represented. Then this is the one of the comparison example of simple bar diagram and multiple bar diagram. Next, we see the two-dimensional diagrams. In the diagrammatical representation of ungrouped data, it can be represented by using one of the thing is circle graph or pie diagram. The pie diagram. Pie diagram is a circular graph that represents total value in circle and components in pathwise. It is useful in comparing components and total value. Data is expressed in percentage of total value. To draw a pie diagram, first the value of each category is expressed as a percentage of the total. The total value is equated as 360 degree. When do we use pie diagram? The data are given in percentage. Different aspects of a variable are to be displayed. The data are to be compared normally. How to construct the pie diagram? The step 1, convert the given values in percentage form and multiply it with 3.6 degree to get the amount of angle for each item. Then step 2, draw a circle and start the diagram at 12 o'clock position. Step 3, take the highest angle first with protractor and mark lower angles successively. Step 4, shade different angles differently to show distinct in each item. This is the representation of pie diagram. Then we go for pictogram. That is the one of the data is represented by picture. It is popular method of representing statistical data in picture. In a pictogram, a number of pictures of equal size and definite numerical value are drawn. Each picture represents a number of units. Pictures are drawn side horizontally or vertically. It is widely used in public and private sector. Mostly pictogram, also known as pictograms, are very frequently used in representing statistical data. Pictograms are drawn with the help of pictures. So one of the pictogram picture is given there. All of you please note it down. The next, cartogram. Cartogram is the representation of the numerical facts with the help of a map. By representing the facts by maps, the impact of the results on different geographical area may be shown and to be compared. For example, the production of wheat in different geographical areas can also be represented by cartogram. The quantities on the map can be shown in many ways, such as through shades or colors or by dots or by placing pictograms in each geographical area or by the appropriate numerical figure in each geographical area. Next, graphical representation of data. The graphical representation of data consisting two parts. One of the thing is graphs of frequency distribution, then graphs of time series. Next, we have to see the graphs of frequency distributions. The graphical representation of grouped data can be represented by using histogram, frequency polygon, frequency curve, cumulative frequency curve, or also called as OGI. First, histogram. A histogram is a plot that lets you discover and show the underlying frequency distribution of a set of continuous data. Size of class interval is represented by width, size of the frequency is represented by height. In the histogram is essentially an area diagram composed of series of adjacent rectangles. When do we use histogram? The data are given in form of frequencies. Class interval has to be displayed by a diagram and we need to calculate the mode of a distribution graphically. The construction of histogram in two ways, histogram with equal classes and histogram with unequal classes. Then frequency polygon. Frequency polygon is another device of graphic representation of a frequency distribution. That means continuous or grouped or discrete data. It is used where class intervals are equal with the discrete variables. It gives idea about the shape of the frequency distribution. When do we use frequency polygon? The data are given in the form of frequencies. Two or more groups have to be displayed in one diagram. Two or more groups are to be compared. Frequency curve. Frequency curve is another type of graphical representation of data. A frequency curve is a smooth freehand curve drawn through the vertices of a frequency polygon. Frequency polygon is drawn using scale, while frequency curve is drawn using freehand. When do we use frequency curve? When the number class intervals are very large, that is, width of the class intervals are very small and the total number of sample values be increased indefinitely. This is one of the example of a frequency curve. Next we see the ogive or cumulative frequency. Ogive is the graphical presentation of the cumulative frequency distribution of continuous variables. The ogive consisting two types of distributions. One is less than ogive, another one is more than ogive. Less than ogive means this consists in plotting the less than cumulative frequencies against the upper class boundaries of the respective classes. More than ogive means the more than cumulative frequencies are plotted against the lower class boundaries of the respective classes. So this is one of the example of a more than ogive and less than ogive. Those two ogives intersecting at some point, that point is called the median of the data. So these are all the brief explanation of a diagrammatic representation and a graphical representation of a data. Thank you. We will meet on the next lecture video. Thank you so much.